Hey guys, welcome to question MM208 of the Maths Methods Fortifier study guide. We've got this function f of x equals negative sine x over 3x take 4, and we need to find f dash of pi on 2. So firstly, what does f dash of pi on 2 mean? Well, firstly we need to find f dash of x, because we're not going to be able to sub that in unless we have that. And what is f dash of x? Our gradient function, or our derivative function. So how are we going to derive f of x? Well, we can immediately see that we've got a function over a function, which means we're going to be dealing with our quotient rule, right? So, what's our function rule? Well, firstly, we're going to have to rewrite this in terms of u and v. So I'm actually just going to say let y equal u over v. I like dealing with y because it's just easier. So I'm just going to say let y equal u over v, where u equals negative sine of x and v equals 3x take 4. Awesome. Now for our quotient rule, we're going to need the derivatives of each of these. So I'm going to say du dx, which is the derivative of this, is equal to negative cos x, and dv dx is equal to 3. Awesome. Just going to go over here. Now, our quotient rule tells us that dy dx is equal to v times du dx minus u times dv dx over v squared, where u and v are these functions here and our derivatives are there. So the reason we did these first was because now we can simply just plug in our values. So we get v, which is 3x take 4, times du dx, which is negative cos x, minus u, which is negative sine x, so minus negative sine x, times dv dx, which is 3, over v squared, which is 3x take 4. Awesome. Guys, around here is our first mark, recognizing that it's the quotient rule and then subbing those in. From here we can get, just rearranging this a little bit, we get 3 sine x minus cos x, 3x take 4, over 3x take 4 squared. Sweet. From here, we're actually going to sub in our pi on 2 now. So dy dx is equal to that. Therefore, f dash of x equals this, right? Because we always want to bring it back to f dash of x, because our original was f of x. From here, we're going to sub in our pi on 2. So f dash of pi on 2. It's always really important to just really concisely convey what you're actually doing all the time. Like, don't say f dash of x equals this and then f dash of x equals something with all the pi on 2's subbed in, because that's not f dash of x, that's f dash of pi on 2. Minus cos of pi on 2 times 3 pi on 2 take 4 over 3 pi on 2 minus 4 squared. Awesome. I'm just going to rub this bit out here so we can come back over here. Oh, and by the way, guys, this around here is your second mark. Yeah, I'll leave that. Awesome. So from here, so sine of pi on 2, let's just rewrite this, f dash of pi on 2. Sine of pi on 2 is 1, okay? So if you're not completely familiar with this, you need to be. So just go and revise your unit circle stuff. You'll be able to find questions like this and practice in the trigonometry section of Fortify. So 3 times sine of pi on 2, which is 1, minus cos of pi on 2 is 0, which means 0 times anything here is just going to be 0, so we're taking away 0, over 3 pi on 2 minus 4. Okay, so 3 pi on 2 minus 4 squared. Awesome. Now, I don't like having a fraction and a whole number as a denominator, so I'm actually going to merge all this together. So 3 times 1 minus 0 is just 3, so we get 3 over 3 pi minus 8 over 2 squared. Right, so all I've done is just merge this into one fraction here. If you're not sure on how to do that, you need to revise your fractions. So, what we get is 3 over 3 pi take 8 squared over 4. So this is still kind of like its own fraction underneath. And I've just got this 2 and squared it, which is where that 4 comes from. Because this is a fraction under a whole number, that 4 is going to multiply by our top. We're going to get 12 over 3 pi take 8 squared. And that's our final answer. So that's the third mark. F dash of pi on 2 equals this. This is our final answer, guys. If you have any questions about that, please hit me up in the comments below. But otherwise, thanks for watching and have a great day.